Yes. Okay, we have a sparse group. You've all heard of the various crises going on, but this is recorded and will be available to my students who hopefully watch this later, or maybe you're watching live right now. Who knows? I can be optimistic. But for fun announcements before we get going, Tuesday, May 26th at 6 p.m., we have our student research symposium that'll be going on in this room and also out in the hallway. So we will have a really wide variety of SWOCC students presenting on what they've been doing undergrad research on. So they'll be giving some kind of short lightning talks. We'll have some posters. We might even have some science art projects talking about different geologic time periods, various things like that. So that'll be coming up. It'll have everything from astronomy to geology to chemistry to, I don't know if we have any sociology this year, but maybe we might. Stay tuned. Do we have any other talks? This is just the symposium is the last one for this term. We do have some more lined up for the fall, but we'll get to those when they get closer. We have already started scheduling talks for the fall. That is so far away in my brain, I cannot remember any of the dates, but stay tuned for the next geology lecture series. Will be on Yellowstone supervolcano, and some good and bad news. The bad news is canceled out by the good news. Basically, Yellowstone is less likely to erupt than some previous models that already had it not very likely to erupt, to spoil the story coming out of it. Yeah, well, totally forgotten by then. I guess the one other thing is if you know young people in the community, we have a STEAM summer camp. It's a week long in August 10th through 13th, and it's a ton of fun. We take kids to South Slough. We will have physics and geology and chemistry and really neat activities for grades 6 through 12. So if you have children, send them our way. If you know children, send them our way. So again, I'm not going to bother to do a big fancy introduction because I think that's part of what the speaker gets to really highlight. But to me, this is a really special speaker because Brittany's one of my former students. So this is a really fun moment where I'm not sure either of us probably thought we would be standing here at the time that we met long ago, where, you know, Brittany got to witness me trying to do programming in a stats class and then teach it to undergrads that were
You did fine.
Slightly more lost than me. And, you know, cat herding around Montana and Eastern Oregon telling students not to pick up rattlesnakes, which, you know, some of them did. Anyways.
I don't know anything about that.
Logan.
Yeah. All right. Thank you so much, Wynn. I appreciate it. Yeah, so I'm here and I have a co-presenter, Madison Callan. She is one of my peers at work that she is presenting remotely. She's actually out in the field at this moment doing engineering geology work. So I want to give a little intro to us. I am Brittany Daly. I'm a licensed engineering geologist or a certified engineering geologist in Oregon. And I am also a registered geologist in Idaho State. And Madison, if you'd like to introduce yourself.
Yeah, I'm Madison Callan, staff geotechnical engineer with Delve Underground, and I have my EIT and GIT licenses.
She's one of our special breeds that kind of branches both. So she's got an engineering and a geology background, and she's pursuing licensure. And she just joined us this year, or about a year ago. So I want to start off with like, what even is engineering geology? When I was going to school and when I first started pursuing this as a profession, I didn't even know that what I do today was something that you could do. So engineering geology is the application of geologic data, techniques, and principles to the study of naturally occurring rocks and soil materials or subsurface fluids. Said another way, engineering geology is a scientific discipline concerned with the application of geologic knowledge and engineering problems. It's essentially applied geology. And what do engineering geologists do? It's $1 million question, and the answer is many, many, many things. Geology is an extremely diverse field, and a diverse field of study. An engineering geologist is a subset within that broad field. Essentially, engineering geologists are geologists who have obtained additional specialty licensing in addition to your registered geologist licensure. That is a combination of work experience, education, and testing. In Oregon, this is known as a certified engineering geologist. In Washington, it's a licensed engineering geologist, and some states don't offer it at all. So there's kind of a gambit across the board. Typical areas of focus specifically within engineering geologists include landslide investigations and landslide stabilization, rockfall hazards, assessments and mitigation, highway and road cut slope design. We do a lot with complex geotechnical investigations, tunneling and ground control, portal and shaft design, rock and soil characterization and for construction sites and foundation engineering, as well as subsidence analysis, seismic hazards, and erosion assessments. So all of that is to say that even though we're a subset within the larger geology, there's still like an incredibly diverse background that you can work within engineering geology. So to start, I'm going to just go through my background and kind of walk through who I am, where I got to, and what I'm doing today and how I got here. I am Britt Daly, and I met Wynn way back when I was going to school. I started going at a community college. I actually was pursuing nursing originally, and I studied it for about a year and a half and realized that I preferred science over some of the other aspects of that, and I veered over to geology. So I actually got my first 2 degrees as a Associate of Art Transfers degree through Lane Community College, as well as an Associate of Science. And I transferred to the University of Oregon, where I got my bachelor's degree in geology. Since graduation, I have achieved a couple of different licensures and certifications. The first being my unmanned aerial vehicle FAA 107 certification. Essentially, I'm a drone pilot license. In 2020, I obtained my GIT. We'll get back to that a little bit. I was a little bit late to the game. In 2021, I got my LG, or my licensed geologist, through Washington State. And then in 2023, I sat for my licensed engineering geologist exam and achieved that. Since then, I've been licensed in 2 different states. I got licensed in 2025 in both Oregon and Idaho through a process that's known as reciprocity with my licensing. So I'm a licensed engineering geologist in Oregon and Washington, and a registered geologist in Idaho. So we're just going to kind of walk through where I started and where I am today. Originally, straight out of school, I went into underground mining and ground control and rock mechanics. And so I graduated with a bachelor's degree. I'm a little bit different in the sense that I was a teen mom. I was a young adult, essentially, in that fashion. So I didn't pursue a graduate degree. I went straight into underground mining and ground control. And I spent a couple of years working in gold mines in northeastern Nevada, doing ground control and tunneling work. And I was able to transfer internally with the same company to Colorado to be an ore control geologist and a void drilling engineer. I spent over 6 years working within gold mining in both surface and underground applications, doing primarily geotechnical and ground control work. In perfect timing, in late 2019, I decided I was a little disillusioned with that. I wanted to return to the Northwest and do some more traditional geotechnical background. And so I came back right before COVID hit. It was fantastic. And I got this amazing job actually working with the Washington State Department of Natural Resources as a state lands geologist for the Olympic Peninsula, where I studied landslide response to timber harvesting throughout the Olympic Peninsula. It was super fun. I felt like I was in like Fern Gully. I spent like 2 years just running around deep in the woods looking for landslides. It was amazing. And given my background in mining, the opportunity presented itself essentially for the role of the mining and minerals manager for the state of Washington with DNR. And I moved into that position where a lot of the work that I dealt with was involved in permitting and compliance on mining applications statewide. Okay, so after I'd been working there for a while, that's about the time that I started to get licensed. So we're going to touch on that, why I was a late bloomer. In both Nevada and Colorado, there is no licensure offered. And also in mining, it's not typically a requirement. So I graduated and I went to work and I didn't get licensed as a geologist. When I returned to Oregon in Washington in late 2019, I took both my GIT and PG exam back to back. I don't necessarily recommend that. But when I did, that was about the time when I was approached by a regional geotechnical consulting firm, Landau Associates, and they offered me the opportunity to start to explore some more traditional geotechnical applications and really get my hands dirty with a lot of the drilling and permit writing and things like that. So I was with Landau for about a year and a half, doing a lot of traditional geotechnical investigation work. From there, I was able to transfer over to the Washington State Department of Natural Resources, or Washington State Department of Transportation, where I was a drill inspector. And what that was is I worked with the state geotechnical headquarters office on their drill crews and actually oversaw the geotechnical investigations. I did all the analysis and characterization of the samples that we were doing and oversaw the investigations in the field that we would then provide to the engineers to do their design work. I was with the Washington State Department of Transportation for a little over a year until I got my license, engineering geologist certification in 2025. At that point, once I obtained that, well, I was approached by my current employer now, which is Delve Underground. And we are a heavy civil engineering group. We specialize primarily in tunneling and unstable slopes. Madison and myself are with the unstable slopes group primarily. And so we do a lot of work with like landslides and unstable slopes reconnaissance, but we also work a lot with tunneling and some traditional geotechnical work. I've been spending the last 3 years really exploring the country. It's been super fun. Here's some pictures I've got. And here I got a. So up here, this is me drilling in downtown Manhattan. I can tell you it's a lot different than anything that you're going to do here, and you really need to make sure your locates are very good, because it's all been reworked 1,000 times. Here we're doing some slope stabilization for Georgetown University right in downtown Washington, D.C. That comes with its own subset of complications, but it was a super fun project. And I've always said that the best geologists have seen the most rocks. And so I'm just really enjoying getting to see rocks nationwide at this point with Delve. You guys might recognize this site. It's just north of Gold Beach. This is a large shaft construction project that we've been working on for the Arizona in Landslide project out there. Madison, my co-presenter, is very well versed in that as well. We are continuing to work on that. And up here, this is the most recent project I just got off of. Here's another picture. That's the I-5 rockfall that just closed down the interstate for over a month or nearly a month in Bellingham. So all of this is to say we do like an incredibly diverse amount of work and different kinds of applications. Okay, so here's where I really want to kind of break it down. What is a normal day-to-day life for an engineering geologist? And the honest answer is every day is completely different. And it kind of works within seasons. So we've got seasons of a lot of field work and then seasons of lulls where you're doing kind of more office work and preparing for the next round. I would say that my field work schedule ranges anywhere between like 30 to 60%, depending on the season and what we're doing. And it generally involves geotechnical investigations, whether that's drilling, sampling, mapping, soil and rock mass characterization, or instrumentation installs. We also do a lot of landslide characterization with all the various different kinds of landslides or rock topples or whatever you have. Emergency response is a large part of what I do currently. So we partner with both city, county, and state agencies to do primarily landslide response or rockfall response, which ties into the above note, and construction monitoring. So in addition to doing the pre-studies on geotechnical investigations, we also are there often during the construction phase and do construction monitoring to make sure that the design is actually as designed. For my office work, that also varies again, depending on the season, but it kind of ranges anywhere between about 70 to 40% of my time. One of the common things with being an engineer geologist is there's field work. Even the principal levels or the very senior levels of folks I work with are generally in the field a certain amount of time. So it's integral to what we do. But when I am in the office, I'm typically working a lot on like geotechnical memos or reports. We write data reports, design reports, post-construction reporting, things like that. I do a lot with geotechnical investigation scoping. I just went out to a landslide yesterday for a county and looked at a slide that they had, and we're putting together a program essentially so we can drill that and design a fix for them. I do a lot with QA, QC field data collected from various field staff and just making sure that everything we have is tight. We do a lot with slope stability analysis, geotechnical log development, lab data reviews, things like that. After we install instrumentation, we also do a lot of monitoring, which can sometimes be years into the future, depending on the scope of the project that we're working on. I also do a lot with business development and outreach. That's why I'm here now, is to try and spread the message of what we do and why we do it. And then we also do a lot with conference participation in professional societies, writing research and papers and presenting in that way. Okay, so here's where if I look back, hindsight's 2020, I've been doing this for over 12 years now. If I was a student, what would I have hoped I would have told myself back then? So here are my words of advice. First one is take the SWOCC exam near graduation, please, as soon as you can in your senior year or immediately after. Geology, again, is such a broad field. And when you start to really focus, you can miss pieces. So I would highly recommend taking the SWOCC exam, even if you don't plan to pursue private practice. It's better to do it around your senior year. Networking is really important. There are a lot of job opportunities within professional associations, and there are also volunteer opportunities, and they're usually hurting for people. And everybody that you're surrounded with are going to be professionals within your own realm. It's an invaluable skill that I was a little late to catching up on myself. And so I think professional networking and societies are like, they're a slam dunk. So when I went to Washington originally in 2019, I was approached to be the chair of AEG. That was completely invaluable for my career, and it's still paying off. So I highly recommend it. Interviews are important, and most people don't really know how to prepare for them. I certainly didn't, and I've since sat in on multiple interviews, and one of my key pieces of advice are to beef up on your STAR questions, and it's a format of answering all the questions essentially that they'll ask you, and it is situation, task, action, and result. There are a ton of videos on YouTube and various courses that you can like watch to help you prepare for that, but it's just something I wish I knew about before I entered the job field. Internships lead to employment. So an internship, in my mind, is a long interview. And it's also a way to feel out a certain job or an application if you're not sure, and really get a feel if it's right for you. So if there's an internship that's not even necessarily the exact right fit for you, I would still say go for it, because what you learn, likes and dislikes, are invaluable there, and it is ultimately a job interview. Ask all the questions. So imposter syndrome is a real thing, and I think a lot of us really struggle with it, and you want to be quiet and you don't want to ask the silly thing or say the silly question, but seriously, ask all the questions. That's not only how you increase your skills the fastest, but it's how you identify your mentors that are going to be there for you, and they're going to help you build your skills as well. Scripting and coding have been useful in every single one of the jobs I've ever had, and I've worked a pretty diverse career. It's something that I didn't really focus on in school, but I wish I had in hindsight, and it follows me today. And then finally, memes are absolutely the best way to communicate with engineers. So when in doubt, find a good meme and shoot that their way first to soften it, and then you can go in hard with it, whatever you need to. It always works. Yeah, so we've got a confirmation in the field. So here, I'm going to pass it over to Madison, and I can click through the slides for you, Madison, as you go.
Awesome, thanks. Okay, hi everybody. I don't know if you can see me, but yeah, I'm Madison. So I'll first go through the logistics and then get to some more exciting photos and what I actually do now. So I have 2 bachelor's degrees from UT Austin. I first started out in environmental science geology, which is basically an environmental geology degree. And then I added on environmental engineering because I knew that ultimately I wanted to be an engineer. But I always had that passion for the earth sciences. And I'll get into it in a minute, but I sort of switched, pivoted a little bit. And for my master's, right after undergrad, I went to UC Berkeley for Geosystems Engineering, which just means geotechnical engineering. So took no breaks and did 5 straight years of school, but got my degrees, and now I'm done. But the exams didn't stop there. So I did take my FE exam in school. Actually, that's not 2020. It should be 2024. My senior year of college, I took the FE exam while all those concepts were very fresh. So that was easier than doing it after school. Like I did for the FG, I took that this past year to get my GIT license. And then I also have the drone pilot license that Britt has. It's a fairly common thing in our company. We do quite a bit of drone work to get cool pictures of sites as well as to map certain things, map slopes. And then hopefully at the end of this year, I'm going to be taking my PE exam. But ultimately, I want to get both the PE and PG licenses and potentially either the CEG or LEG, like Britt mentioned. Yeah. Okay, so I figured I would just throw in my internship since my current job is my first real job. So in college, I did 2 internships. The first was as an environmental engineering intern with a company called Anchor QEA. And I was doing mostly office work on permitting, some basic report writing for all sorts of coastal restoration and water resources projects, mostly located in Texas. So that was my first real introduction to what environmental engineering was, since that was one of my degrees. And that internship taught me that I did not enjoy environmental engineering. So that is why I pivoted. And the following summer, after I graduated undergrad, I interned as a geotechnical engineer for a company called ANS Geo. They don't have any, you probably haven't heard of them because there's no offices on the West Coast, but I was mostly in the field, which is where all of my cool field photos here came from, doing typical geotechnical explorations. I was drilling, doing test pits, a lot of geophysical testing, ERTs, ERIs, MASW, even got in some rock coring. And that was a really great opportunity to just learn all of the basics of geotech investigation and spend 4 months in the Texas heat, sweating it out and learning how to identify soil and rock. So it was a great opportunity to really immerse myself in these basic field concepts. And now I feel that I could take that knowledge into my current position. And I already know how to classify soil and rock. But yeah, so that internship sort of gave me a taste for what it was like to be in the geotech / engineering geology field. And that's why I pursued my master's in it. Okay, so the more exciting thing is what I do now, and I put the word slide first, but the photos will come. So for almost the past year, I've been working as a staff engineer at Delve, and these percentages are very rough. They vary quite a bit depending on the time of year. Like Britt said, sort of fluctuates. So first would be my field work, which is probably half to a little more than half of the time, but again, it depends. And so far, I have mostly done various types of construction monitoring. So I've been out on construction sites that we have designed, and I've been overseeing the construction and mapping certain things and monitoring certain things. So what these have been are trenchless installation projects. So we design sewer and water pipelines. So I'll go to those projects and I'll log the horizontal drilling, and watch the trenchless installations underground and monitor the ground conditions. Primarily, I've been on drilled shaft and tunnel sites, which is where a lot of my cool photos on the next slide will come from. But yeah, so we design fairly big shafts and tunnels, and we have to have somebody on site during the construction in order to monitor the ground conditions and keep an ongoing record of the rock, which is actually where I am now. We're putting in 2 drilled shafts up on the Canadian border. So those are really cool because they're super large scale projects. I actually get to go down in the shaft or into the tunnel, and that is honestly my favorite thing. And again, I'll show some cool photos in a minute. Also in the field, mostly what I'm doing on these sites, like I said, is soil and rock mass characterization. And then sometimes I'll do subgrade inspection, which is pretty easy, but that's more of typical geotech. You need subgrade compaction for certain foundations. And then in terms of my office work, which is about half to a little less than half, but again, depending on the time of year, I do a lot of different things in the office. It's going to sound like more engineering than it sounds like geology. But I like it. I like doing the design work. I think it's really cool. One of the things I do is help with tunnel support design. So I get to use a lot of cool software to do that, to monitor or to model the rock wedges that will form in tunnels, and then determine what support we need in terms of shotcrete or rock bolts. I do a lot of slope stability analysis. Britt also mentioned that. So when we design these trenchless installations or these shafts or these tunnels, there'll be certain rock cuts, and we'll need to check the global stability of the slopes. I also spend a lot of time reviewing and editing and looking at design drawings and specs. And I put this in here because this is one of the biggest, not challenges, but it was something very new to me coming out of school. I had never seen what a design drawing looked like. And so it took me quite a while to figure out what I was actually looking at, because these drawings get very complicated. There's a lot of small notes and small writing and numbers and dimensions. And I think that if you can get some sort of experience looking at those and becoming familiar with them, that would really set you ahead, because it took me a while to get familiar with that, but now I'm using those on a day-to-day basis. I also do a lot of memo and report writing, which everybody in the geotech field does. But yeah, typing up what we see in our explorations and putting it all in writing and sending it out to the client. And then some smaller things. I've done a couple micropile design projects and various calculations for drilled shafts. Yeah, just thought it was important to note that when you're an entry-level staff, you're doing a lot of miscellaneous calculations. So that takes up a lot of my time as well. And then one thing that I like doing is, although it's mostly just sort of paperwork, is something called RFIs and submittal reviews. So when projects are in construction, the contractor who's actually building it will submit RFIs and submittals, which are essentially changes or questions to the design drawings and specifications. And I really like doing this because I feel like it really allows me to become familiar with the project and really makes me think about, why are they asking that question, or why did we put this in the drawing, or why did we leave this out of the drawing, or why did we put this in the spec? And so it's sort of an admin paperwork task, but I do spend a lot of my time doing that as well. Okay, now for the cool photos.
Oh, yep. Okay, there you go.
Yeah, so I broke it up into kind of two separate aspects of my field work, the first being shafts and tunnels and the second being drilling. So these are some cool photos from shafts and tunnels that I have been at in the past year. As you can see, some of these photos are from down at the bottom and some of them are from the surface. So I actually do get to go into these shafts and tunnels and see the rock and touch it and map the rock. And so this is where the geologist in me really shines. I love taking my rock hammer down there and hitting things and you know, noting the strength and seeing the fresh rock. That is really what excites me before it gets covered up permanently or excavated permanently. So yeah, some of these sites are they're all over Oregon and Washington. One of these is at the Arizona Inland Slide, like Britt mentioned. A couple of these are closer to Portland. I don't think I included. Yeah, that's where all these sites are. But yeah, thought I would appeal to the geologists in the group and show some cool rock photos. And then the next slide is some drilling applications. Surprisingly enough, I have not done any regular borings, like regular SPTs with Delve yet. I know it will come. So these are more large scale drills, but still very cool, both horizontal and vertical drilling and some of these trenchless installations. Yeah, it's cool being around such large equipment and logging this on a larger scale. It's kind of different than doing a typical geotech investigation because you don't know exactly what depth you're at. So you have to interpret things just based on spoils. You're not getting an intact sample. So kind of a different application, but still very cool. I like going to these large scale sites. Okay, and then I think on the next slide I have some cool aerial photos. Yeah, so before I do the words of advice, the top photo I took while flying the drone at Arizona Inn. So I spent a lot of my time over the past year there monitoring their construction progress. And then the bottom photo is where I am currently right now. It's a gold mine up in northern Washington where we're putting in 2 shafts. So I thought that was a really cool view to share as well, that this job gets to take us very cool places. But yeah, so in terms of my words of advice, my recommendations over my long career spanning 1 year, the main thing I've learned is to say yes to any opportunity, even if it's not your top choice. So I really try to hold myself to this because there's certain things that I don't necessarily want to do, but I will say yes to them because all experience is valuable. And especially if it shows you what you don't like doing, that's sometimes even more valuable than doing something you do enjoy. But that's why I work on so many different projects and so many different applications and even small one-off things, is because I always say yes and I will always figure out a way to get it done. Because I think that so early on in my career, it's really, really necessary to try everything and to not sort of pigeonhole myself on one aspect of geotech or engineering geology, but to really get a taste for every application, because I'm sure that later on in my career, I will be able to specialize more. Second word of advice, which might be more applicable to those in school right now, is to tailor your range of skills and experience to a specific job application. So when I was in college and then in grad school, I applied to a variety of internships and jobs in different fields. If you remember, I worked in environmental engineering and then switched to geotech. But I have taken that experience, although some of it is different. You might think, how would environmental engineering apply to geotech? And I've tailored it to specific job applications and found ways to talk about that experience and make it applicable and show that I learned something so that it didn't go to waste. So truly any experience that you have can fit for whatever job you're applying to. Third piece of advice is to ask questions during interviews. I feel like a lot of people forget about this and don't prepare for this. And then at the end of the interview, when the company asks, do you have any questions? You just awkwardly sit there and say no. But it's really important to have at least one question prepared, because it really shows that you're interested in the company and you took the time to ask them something. So literally any question, probably not what's the salary. Don't ask that on your first interview, but some sort of thoughtful question can really help your interview process. Another important thing, as Britt really hit home, take your licensure exams as soon as possible. I thankfully took them very close to school, but even taking the FG, the Fundamentals of Geology exam, 1 year after undergrad, I already forgot things because it's such basic geology concepts. You don't think about, like, I don't think about those things in my normal day-to-day at work. And so I really had to go back and rememorize a lot of these basic textbook concepts. So highly, highly, highly recommend taking those exams in school or right after and just get them done, get them out of the way while the information is fresh. I also really recommend joining professional organizations. I'm sure you've heard this from a lot of people and probably heard speakers from them as well, but it is really helpful. Even if you just get the free food out of it and get to have a conversation with somebody that you wouldn't normally have a conversation with. But in addition to joining and putting it on your resume, actually attend the meetings, because you never know when you're going to need to interact with somebody that you met at one of those meetings, and those relationships that you form can actually become really valuable. Or you can remember something from someone's one-off presentation and it'll really become useful in your career. So highly recommend joining those and actually showing up. Kind of going alongside with that is to actually introduce yourself to others at those meetings. So don't just sit there in the corner and talk to your friends, but actually go and interact with people in the industry and get their business card. Even if you don't have one to give back, get their business card and keep it. I still have business cards from college shoved in my desk drawer, and maybe they will become useful one day. I have some sitting on my desk, and sometimes you'll remember people's names, or you'll see it pop up in like a LinkedIn post, for example, and then you'll be like, oh, I met that person at this AEG meeting. So it can really become useful in the future. You never know. So definitely introduce yourself, make conversation, talk to people, and hear what they do for a living. And then finally, the last thing, which has probably the first and the last bullet point are what I've really learned over the past year of working. Confidence is key. So a lot of what I'm doing for the first time, right? I didn't learn all of these concepts in school. I didn't go to construction sites like this in school. And so a lot of this is new to me, but you really have to show that you're confident and that you believe in yourself and in your skill set and in your education to be there and to do this work. And it's sort of like fake it till you make it, but obviously you don't want to act like you can do something you can't, but just to have confidence and really step up and get the job done. And being confident doesn't mean that you can't ask people questions. I ask people questions all the time. But it just means that I'm confident in the work that I do, and representing my company when I'm on these sites and interacting with other people. I think that's it from me.
I think so. Thank you, Madison. So now I've just got a couple of videos, because what is a presentation from engineering geologists if not a couple of videos, right? So first I want to start, I don't know if you guys have seen production blasting and mining really before, but I've got a couple of examples here. First, we're going to start with what a good blast looks like. And this isn't the best blast I've ever seen, but it's pretty good. Volume. There we go. There it is. That's some blasting ASMR. So we did have one misfire on the end there. Did you guys catch that? So now I've shown you a pretty decent blast. We're going to look at what a not so decent blast looks like. 2, 1. Fire. I think you can tell what's not so good there. A good blast should just look like a motion through the rock. You don't want this big explosive thing. So that was what we call a Rhine shot. Fortunately, it was shot a little bit too far. Yeah, that too. So this next one is one of my favorites recently. I touched on it earlier. I was dispatched as a part of the emergency response for the I-5 rockfall that just shut down I-5 northbound south of Bellingham for about a month. One of the fantastic things that we got to experience there was their amazing communications group that was working with us to try and communicate why the road wasn't open yet and why it was taking so long. And people don't really understand that and all the things that go into it. And we had these fantastic contractors that were working with us that like to film what we were doing. And they were working with the communications team. And it actually really kind of saved our butts because they were able to communicate with the general public about the severity of what we were doing and why it was taking so long in a way that got people excited. And here is that video. That's what that is. All right, so with that, I would like to open it up to any questions anybody has for Madison or myself.
You want, I can give you the microphone so that Madison can hear on Zoom.
So I'm an engineer in the area here, and we see a lot of like after the fact things where someone will call us after a landslide happens, let's say, and it's an unstable situation and you want to get in and get some geotechnical information, but a drill rig isn't like very feasible. Do you have any recommendations in terms of remote sensing options or drone technology that can kind of help paint a decent picture, at least to sort of start the problem solving?
Yeah, so UAV or drone flight and imaging is one of the first steps that we take with reconnaissance, whether or not we're going to go there with drills. Drilling can be complicated, and I will say we can get a drill on just about anything.
Okay.
But it takes a certain amount of money and lead time. But yeah, there are softwares out. The technology has advanced a ton. So I first got licensed as a drone pilot in like 2018. Between now and then, it's a whole different world. There's the software Pix4D that you can fly with a drone right off the market and collect a point cloud and create a 3D surface off of. And you could put that into an application like GIS or ARC or whatever to do your design work. And so it's definitely out there, but you would need a firm that kind of has that background in it.
Anyone else?
I have a question. How fast is the, I don't want to talk in the microphone. No, I don't.
Just one.
How fast is the, north of Humbug there, south of Humbug, north of Gold Beach?
How fast is what?
How fast is that slope still moving?
Well, it's a creeping slope. If we have anything to do with it, we're going to slow it down significantly. So we're dewatering it currently. There is still slow creeping ongoing. Yes.
The asphalt's getting stretch marks again.
It is. Yeah. It is decreasing with time. And there's actually a pretty amazing amount of instrumentation in there that is being monitored on the regular though. So if it increases or accelerates the rate of deformation, it will be notified quite quickly and addressed. But it is an ongoing creeping landslide.
Follow up to your comment, what is the interface between what you do and hydrology?
Oh, good question. Hydrology scares me, if we're being honest. I work in solids. Oh, perfect. Yeah. So we got the hydros here. So we work actually a lot with hydrology. And we do a lot of testing on groundwater, pore pressure, groundwater pressures. I do like hydrojacking, VWP instrumentation, a lot of hydrology. As far as the analysis of that though, we've got in-house professionals, essentially our hydrogeologists or hydrologists that we send to for the assessment on a lot of that. But it's integral in everything we do. Groundwater is a massive influence on all of our engineering designs.
So I have several questions
Wonderful.
that you may or may not be able to answer. So the wells that people dig
Mhm.
for water, are you guys noticing in areas, Washington, Oregon, the water production or whatever lessening due to maybe climate change, et cetera, that kind of stuff?
Not really at the scale that we're tracking them, but I would caveat that with usually our scope is involved within like 6 to 12 months of monitoring up to a couple of years. So for our applications, we're not really looking at like a decade or like large global changes in the water flow. It's more isolated than that.
And then can you speak of how wells typically do in Cascadia events? Wells and septic tanks and leach lines?
Yeah, that's a really good question. And I haven't worked with that extensively, but seismic events would impact them for sure. I would imagine, but that's not something I really worked with.
And then evidence of landslides after Cascadia events in Washington and Oregon?
Oh yeah, yeah. So the whole like landslides are everywhere, and
Right.
we rank them essentially from like a relict extinct landslide to dormant to active, and there's the whole in between. And so a large part of what we do when we go out and do landslide characterization is not only to identify that a landslide is here, but how active is it? And many of the landslides that we see are relict or they're ancient, and so they're not necessarily moving today, but they have clearly moved at some point in the past.
Okay, so for a Cascadia event is what I was after. for
Yes,
evidence
so
of that.
it could be tied to either Cascadia or glaciation, or there's a variety of things that could influence those.
And I'll actually jump in on that one. The last class I took in grad school, stupidly the quarter before I finished my PhD, was a neotectonics course. And our big project for the class was we went out and looked at landslides that dammed creeks, that made lakes, that drowned trees, to try and see if we could core and date the trees and see if they were Cascadia. And the two massive problems that came out of it are, how long after Cascadia do you consider it Cascadia triggered? So we found some landslides that occurred within 20 years of 1700. But is that just landslides happen all over in the Oregon coast, or is that Cascadia destabilized it? And then the vast majority of them were more linked to climate than they were to earthquakes. We never ended up finding one that was exactly 1700.
And so I will say for a lot of what we do, by the time we arrive on site as geoengineers to work with the landslides, if they're ancient landslides that happened hundreds or thousands of years ago, unless they're actively moving today, they're usually not calling us. They're calling other professionals. So that would be the caveat I'd give, that I don't really work so much with the correlation of the ancient landslides in today.
I did not take SWOCC my senior year, and that was a really long time ago. Is it too late for me? I kind of want to take it.
No, it's never too late. And if I am anybody that can speak to that, it's never too late. I was a solid 7 years into my career before I took any of the exams. And frankly, I didn't really expect to, because I was planning to be in mining originally. It is more difficult. I would say you need to refresh more and study maybe a little bit longer if you've had a gap, but it's absolutely doable.
Yeah, I also worked in mining. What is on it? Like, I've worked in geotechnical geology a bit, and my background is in volcanology, and I know a lot of structural geology because I recently been working with WIN and some structural geologists. So what am I missing?
Oh, we should have an after talk about that, because there's a lot of subjects on it. It's very diverse, and both tests are kind of different, right? So the GIT, the fundamentals, is going to be more your basic concepts. That's like the breadth of what you study in an undergrad, whereas the PG is going to be more of an applied geology. So they're going to have more situational problems that you need to work through. And I'd be happy to sit down and talk through it. But we can go through it.
So my question is, what do you do when, say, ODOT is like, hey, we need you to fix this giant landslide over 101, but it's 101 and it doesn't have as much traffic, so they won't fund what needs to be done to really, truly fix it. What goes into your, what kind of evaluations are you making? Are you planning for 10 years, 20 years, 2 years?
That's a fantastic question. And it's kind of collaborative, right? So when you're working with clients like that, if they don't have the funds for the forever fix, you look at maintenance, you look at alternatives, you look at prioritizing this slope over that slope based off hazard assessments and its impact to the community. And that's all an integral part of the conversation from the very beginning to the final execution. And that was, so the Bellingham I-5 slide that I just got back from, a big part of that was communicating with the public, like why we're doing what we're doing. We could open it faster, but it wouldn't be as secure and it'd be one lane. And so it's a dynamic process that goes on with not only the engineer, the geologist on site, but also the client and the manager and all the people, who's funding it.
I have a question for your colleague,
Wonderful.
and that is, what role have you found your background in environmental engineering has played in your field work?
Oh, good question. I don't know if it's played much of a role in my field work because most of my environmental stuff was in school and then in the office. Maybe a little bit on the hydro side, but I also did hydro in terms of geology, so that might fall more on the geology side as well. Mostly in environment, I guess I would say probably my fundamental engineering concepts were most useful. So sort of the general civil classes related most to my field work in terms of like the engineering calculations and basic design. But more of the environmental specific stuff like air quality and hazardous waste, that I don't do anything with that now.
I'll caveat that with, we just haven't sent Madison on one of those projects yet. We do have them. And typically they're involved around industrial sites, or if we're working on ports and things like that, there's definitely an environmental component to it that is brought in. And that typically involves sampling and then testing in an accredited lab.
Have you ever run into any serious oops in drilling tunnels?
No, and I don't know anybody that has. Yeah, actually, I mean, you never know. If I've learned anything, you don't know what's going to come next. You can prepare and you can study and you can be well informed, but you don't know what's there until it's there. And it never changes, you know? So I've been drilling when I was underground, for example, we were developing this exploration drift, and you do drilling ahead, you think you know what's there, and there's all this exploration and can still miss things. And we hit a pretty major fault that was not modeled in that, and it was water bearing. And we had to abandon that whole part of the mine, and we had to support it and close it up. And that was a big oopsie, and it stopped development for a long time. And so those things do happen. And that's a big part of the importance of why you really need to study your stuff and be confident about what you're going to do, but also have a backup plan if it doesn't go that way, because sometimes it just doesn't.
I stole a question. My
Okay.
bad.
All right. That's all fair.
So more specific, I guess, to like RFIs and kind of the construction process. Like you start with a geotechnical exploration, right, to try to get the best design information you can, but it's dark down there and you don't really know that you can interpolate between your data points. So it sounds like this comes up fairly frequently. What are some of the strategies that you sort of find yourself coming back to regularly when you do kind of see these unexpected surprises that sort of require at least revisiting the design, if not changing it?
Great question. And feel free to speak up, Madison, if you have input. But for me, it's document, document, document. I am an over documenter. I take so many pictures. I write everything down. I record everything. I document everything. So then if something goes aside, you have something to refer back to and to lean on. And it's also extremely important to have good communication with all of the people you're working with, whether it's your coworkers, the subcontractors that you're working with, or the contractors, so that when these things come up, you pivot. There's a big focus on safety and briefings each morning. So a very regular thing that we do in our industry is every day we get together with the contractors, ourselves or subcontractors, and we line out what we're planning to do for the day. And we come up with, we have a safety talk and staging areas, and we discuss those things because you need to be proactive. So if or when they happen, you know how to react without needing to reinvent the wheel.
Yeah, I can speak to that a little too. It's a very relevant question to my week this week up here. We were drilling and encountered a granite boulder, which is likely a glacial erratic, which was not in the boring logs, not in the GDR. We did state that boulders could be encountered, but we never said anything about boulders of this size and of this strength. And it's situated right at the toe of the slope that we're putting the shaft in at. So the contractor spent like 3 hours trying to drill through it and made 2 feet of progress. So it's all about, like Britt said, documenting. I'm constantly taking pictures. I'm constantly writing down what they're doing. I'm noting the drilling noise. I'm noting when they're changing out teeth on the auger, everything, because they can submit a differing site conditions report. And so noting all of that is really important. Also working with the contractor or whoever it is in that situation to try to work through it. So, I went over and I asked if there's any other way we can excavate it out, if there's any other equipment we can use to break it up, and discuss the plan with them going forward, and try to make a plan so that it doesn't affect the rest of your plan and the rest of your schedule and delay things. So that was a big thing this week, was how do we deal with this without delaying concrete delivery, for example. So yeah, it's, anything can happen in the field. We drill, but yeah, exactly. You can't draw solid lines. You can only draw dotted lines, and sometimes your borings are 30 feet away from where you're actually putting in the shaft in our case. So yeah, just being prepared and documenting and constantly being aware of what's happening, and not becoming complacent, I guess, is another aspect of that. But that was a great question.
Yeah, I always expect change. I don't think I've ever worked on a single project in my entire career that went exactly as planned. And that would be my advice to everybody. There's always something that you're gonna, and I think that's kind of the fun of it, usually, not always. But that's a dynamic part of what we do.
Well, let's,
got another.
Do you do your own drone work, or do you subcontract that out?
We do that all ourselves. When I worked in mining, we would contract it out for the actual data processing. We had a firm that did that for us, but at Delve, we do all the drone work ourselves. So we fly it, we model it, we process the data and create the solids out of it.
What drone do you use?
Good question. So we use DJI drones primarily. We have a variety of fleets. I really like the Mini 4 Pro. Personally,
You're just using photo or video. You're not using LiDARs?
No, we're not equipped for LiDAR. So if we need something that accurate, we typically would contract that out. So for the I-5 rock fall, the Washington DOT actually dispatched their drone folks because they were able to do LiDAR scans for us in that application. Typically, we're doing like an ortho photo and creating a solid based off that. Oh, of course.
well, thank you so much, both of you, for a talk that none of my students are here for, but hopefully we'll watch online.
Oh, this has been great.
Yeah, thank you for having us.
And if anyone else wants to join for a beverage, we are going to go to Nobi's after this. They have non-alcoholic and alcoholic options.
And I will, I've got some cards here that I'll leave behind as well. And I have some pamphlets that you can pass out to students if they're interested. They go over some of our unstable slopes work. It's kind of exciting.
We'll harass students because we have both geology and engineering students.
Oh, I love that. Thank you so much.
Thank you.
Do you know if IT is gonna run back over, or do I need to stop it?
You can stop.